So welcome to my talk, Getting Started with CI/CD for Cloud Infrastructure. Let's start with a little motivation on why we want to talk about this topic and why I think it's still relevant in the DevOps context. So when we look at the cloud infrastructure landscape today, then we see that tools like Terraform or Pulumi or also Ansible are well established. We even see teams using pipelines for infrastructure automation, but still we see that infrastructure changes take ages until applied to production, and that it's often more of a pray and hope approach than a fully automated process or procedure. So within this presentation, I want to talk about how we can deliver infrastructure faster and safer. First of all, by making changes in really small batches, and by making the process that simple and easily reproducible. And last but not least, we will also show how to still provide a proper audit trail for this automation and this working in small batches. Before we jump into the content, let me quickly introduce myself. My name is Michael Lies. I'm an infrastructure consultant at ThoughtWorks. If I'm not working, I'm mainly a father of a little boy and a little daughter. I live in a town called Tübingen in Germany, and my hobbies are cycling, woodworking, guitar playing, and if you want to follow along my professional life, you also find me on LinkedIn. To give this talk a bit of a structure, I want to introduce you to what we call the 3 principles of continuous delivery for infrastructure. And you might easily realize that there is more to that than just writing infrastructure code. So the first principle, and I hope this is clear, is that to get started with continuous delivery for cloud infrastructure, first of all, you have to make sure that everything is in code and in version control. And by everything, we mean, of course, the infrastructure code as such, but also all configuration, be it for the tooling or be it to separate different environments like production, pre-production, test, development. Then also the tests you write for this infrastructure code. You can even put compliance rules in code nowadays. You should have the pipeline and also the automation scripts in code. The second principle is that you should continuously test and deliver all work in progress. So this means that you have to build some quality into your code. You need a safety net of automated tests to allow for running your infrastructure code in an automation. Ideally, you test as you work. So with any new resource that you add or new infrastructure code that you add, you should write along some tests. You should integrate any code changes at least daily to make sure that if multiple people work on the code base, the code still is doing what's expected and that all the changes work together as expected. Thereby, you should always aim for reproducibility. So this means that you can recreate any state of your code easily and in an automated way. And you also want to provide an audit trail of changes along the way to make visible who did what by when. And the third and last principle is that you want small, simple pieces of infrastructure that you can change independently. And by that, reduce the complexity of the changes, but also of the infrastructure code as such. You have shorter feedback cycles because both the pieces that you manage, but also the changes that you apply to the code are rather small. And by keeping them small, you also reduce the blast radius. So this means the effect of something goes wrong. And you can also apply proper permission boundaries if you make the infrastructure components or modules rather small, because this avoids the situation where you have to grant wildcard access to a whole department or your organization. So after we agreed upon those principles, we can jump into the implementation. And first of all, look again at what this everything as code really means. So this folder structure that you see on the left is just a prototypical structure of an infrastructure repository. And it mainly shows that starting with the infrastructure code, the pipeline definition, the various configurations for both the tooling, but then also the tests policies, a quick documentation of how to use this repository, how to get started, the configuration for Terraform backends, and then the configuration for different environments. All this is stored in a repository, which gives us traceability more or less for free, because every change that is done to this repository or that is done to your code base is actually tracked as a commit in the repository that has an author, that has a date, that can have a tag once it's deployed to an environment. And by that, you have a nice history of who applied which changes to your infrastructure. It also allows for reproducibility, because the tooling, so all dependencies to tools and the infrastructure code, but also the configuration and the pipeline, everything you need to spin up the infrastructure is always versioned together. So it allows you to jump into any point of time and recreate the state back then. A little warning should maybe go out when it comes to branching strategies for infrastructure code, because briefly, branches and infrastructure as code don't go well together. And I mean, as a rule of thumb, you can maybe say if you use branches, then merge them at least daily to make sure to fulfill this criteria of integrating all changes at least once per day, which is a core requirement for continuous integration. With this folder structure in place and everything being properly versioned in a version control system like Git, we can already put a check mark to our first principle and move on to the second one. As a kind of an introduction for the second principle of continuously testing our infrastructure changes, I want to introduce you to a concept that we call the Swiss cheese testing model. And the basic idea is that you add multiple layers of tests behind each other, so that even if none of those methods in isolation would provide you a good safety that your code is doing what's intended to do, at the end you can still filter out most of bugs and most of errors that could potentially slip through individual approaches. So we start usually with something that we call an offline test. These are very basic checks of your code base. This could be a linting, this could be some checks that all variables are properly initialized. And those tests can usually be run just before every commit or as a very first step in an automated pipeline then later on. The next layer of tests is an online stack test. So we come to the concept of the stack in a minute. But what we mainly mean by online testing is that for the first time now, the infrastructure or parts of the infrastructure are already created at the cloud provider, for example, and that you run tests against this up and running infrastructure. But the first layer of tests is still on the individual pieces, which then brings us to the next layer of integration tests that spin up multiple pieces in combination and run tests or journey tests, again, a wider range of resources. And last but not least, you need good production monitoring to make sure that even if an error slips through to production, you can easily spot it and fix it before it really hits your users or customers. So let's go through those testing layers one by one and see how we can implement them. Let's start with the offline testing. So in this sample folder structure you see here, we have now two new folders or files. The one is the policies folder that contains policies as code. and the other file is a config file for Terraform linter. And what we can now do already in the dev environment, so this means on the development machine of the person writing the infrastructure code, is that we do a simple initialization of Terraform and then run a first validate to check, for example, that all variables are properly initialized. Then we can run a linting with tflint that checks that our code complies to any coding guidelines that we agreed upon in the team. And last but not least, we can run a policy check to filter out any code that does not comply to our policies. What we achieve by that is that we shift left quality, security, and compliance to a certain extent. So what we mean by that is that we want to tackle software quality as early as possible in our development workflow. Do not postpone this to any team that only comes in very late in the cycle and, for example, does a review of your pull request or something. If you can already run it on a developer machine, then do it even before the developer commits or pushes any code to the repository. We can then move on to what we call online testing. Again, in the online testing, we spin up our infrastructure for the first time and run tests against these created resources. And a framework we often use for that is, for example, TerraTest, that allows us to write test cases in Golang. And all you have to do is cd into the test directory and run a Go test. What is very important if you write such tests is that you do not start to test the framework as such. So this means you should not test whether a resource that you declared within Terraform then also exists after you executed the code or applied the Terraform code, because this is built into Terraform, right? So do not test the tool as such, do not test the framework, but make sure that you have valuable tests. For example, if you create a database, a schema, and a user, check whether this user, given the credentials that were created, can actually log into the database, because this is beyond what Terraform can check and test for you. It doesn't know about those higher level workflows. We can then move on to what we call online testing. Again, in the online testing, we spin up our infrastructure for the first time and run tests against these created resources. And a framework we often use for that is, for example, TerraTest, that allows us to write test cases in Golang. And all you have to do is cd into the test directory and run a Go test. What is very important if you write such tests is that you do not start to test the framework as such. So this means you should not test whether a resource that you declared within Terraform then also exists after you executed the code or applied the Terraform code, because this is built into Terraform, right? So do not test the tool as such, do not test the framework, but make sure that you have valuable tests. For example, if you create a database, a schema, and a user, check whether this user, given the credentials that were created, can actually log into the database, because this is beyond what Terraform can check and test for you. It doesn't know about those higher level workflows. And what is very important then is that once you tested your code base, you do not want to touch it when you apply it to different environments. So this means once you run the test in a dev environment, you want to have the very same code base with a different configuration attached to it and run it, for example, in pre-prod and later on in production. By that, you can avoid any untested snowflake environments that use different code bases, right? So once you make sure that the code base is such with the properly factored out configuration is used across all environments, you reduce the risk of something going wrong basically to configuration changes that you can only test once you apply the code. And this minimizes the risk of something going wrong in production. So once we have a code base where infrastructure code is clearly separated from any configuration for individual environments, we can start thinking about a structure for our pipeline. We usually structure a pipeline in multiple stages with the idea that all the tasks that you can run quickly with low effort, fast feedback cycles run at the beginning. So here, those would be the offline tests that usually run within a matter of seconds. And then in the next stage, we would apply a configuration for a test environment, apply the code in an online test, and have what we call a stack test stage that tests an individual piece of our infrastructure code in isolation. And once this stage is passed, we move on to an integration test stage where we test multiple such components in combination with each other and can have more higher level tests covered. And once this stage is green, we move on to the production stage where the code is finally applied to our production system with the production config. And passing those stages is what we usually call promotion in a continuous integration environment. And with each stage, we can be more certain that the code is actually doing what's supposed to do before we really apply it to production. And once again, I want to mention that this promotion of the stack code across multiple stages happens without any code changes, because the only changes that you make when applying the code to different stages is a change of configuration. So the infrastructure code as such should stay completely the same across all stages. What we now get from executing these different steps in a CI pipeline is a workflow that should be very familiar for our developers. So when you now compare writing infrastructure code to writing any application code, it's basically you write your infrastructure changes, you implement your changes, you commit your changes, and you push your changes, and then the pipeline kicks in and does all the automation for us, right? So this helps that any developer in a team can basically start working on infrastructure and doesn't have to care about how do I install Terraform, which version do I have to use, which permissions do I need to access my cloud provider. And also you avoid all those cases where a misconfiguration on a local machine can potentially damage the infrastructure, because you always have a very well-defined environment for executing those changes on a CI server that is automatically reproduced with every CI run. With this sketch of a pipeline now in place, we can also put a check mark on the second principle for continuous delivery for infrastructure, namely continuously test and deliver all work in progress. We showed how you can use both offline and online tests to build quality into the infrastructure code you create. We saw how you can test as you work. The pipeline and the automated workflow allows you to easily integrate, which in turn allows you to integrate at least daily and work in small batches. The pipeline gives you easy reproducibility, no need to spin up any local Terraform stack and make sure all configuration is in place. And by having all the bits and pieces in version control, we also get an automated proper audit trail, last but not least by the logs and execution of the pipeline. Let's now talk about the third and last principle of continuous delivery for infrastructure code, which is working in small, simple pieces that you can change independently. And to highlight what this actually means, we might want to look at how capabilities and technology is usually structured within our organization. So at the very top, you want to provide certain business capabilities. You can also call them products or applications. So these are the services that your organization provides. On the other end of the scale, you have infrastructure resources that are usually provided by public cloud providers like AWS, Azure, or Google Cloud Platform. And now the question is, how can you bring those two layers together? And for that, any organization usually builds what we call technology capabilities. And in a very sophisticated form, those are sometimes offered as something like an internal development platform. And when you now zoom into one such a technical capability, you find what we call infrastructure stacks, which is a collection of cloud infrastructure resources that are usually managed together as a group. And to give you some examples, what those could look like, one such a stack could, for example, be a Kubernetes cluster with node groups and a load balancer. Another example would be a key vault to manage secrets together with roles and groups. And last but not least, also a virtual network like a VPC could be such an example. You might now ask yourself, what are good criteria for slicing such infrastructure stacks? And I want to give you a few examples that might help you. So a first criteria might be the team or application or domain boundaries for which you create infrastructure resources. The idea here is that you slice infrastructure around the teams that later on use this infrastructure and also extend or change it. A second criteria might be change frequency. So coming back to this example of the Kubernetes Key Vault VPC from before, then a key vault and its permissions might be the things that change most frequently because there are constantly new permissions being added or revoked. Then the Kubernetes cluster is maybe something that has the second most changes because you frequently want to update to the newest Kubernetes version or change something with the configuration. And the thing you least update is the VPC. A third idea is the criteria of permission boundaries. So in order to allow only the group of people to change certain parts of the infrastructure that should have actually changed permissions, you might want to slice your infrastructure in such a way that you can provide those permissions with a principle of least privileges. And last but not least, you can also slice them around technical capabilities. So this Kubernetes cluster as one capability might be a good example, although it's used by multiple teams and maybe contains certain substacks or elements that have a different change frequency, also different permission boundaries. One thing we want to highlight is that you could easily overdo it with reuse, and then maintaining those modules or stacks easily becomes a bottleneck for your teams. So if one team is dependent on another team to make changes to infrastructure, and you do this just for the purpose of reuse, you might rather go on the copy some code side and have some redundancy rather than creating organizational dependencies amongst your teams and making one team become a bottleneck for another team. With this idea of stacks, we can also put a check mark on small, simple pieces that you can change independently. And I hope now you have a good understanding of what we mean by those small pieces and how you find them. Again, we do that to reduce the complexity of infrastructure components, thereby shorten the feedback cycles if you need to apply changes to them, reduce the blast radius. This is what happens if something goes wrong, how much infrastructure is affected, and also be able to apply proper permission boundaries to those infrastructure pieces. A question we get asked frequently when starting with infrastructure automation in new teams is, how do you actually get started? And the answer to that is, what we sometimes call the walking skeleton. So in practice, this means you should start with infrastructure automation right from the start of your project. You should start very simple and thereby lower the barrier of getting everyone in the team involved. So by very simple, we mean a pipeline in the first iteration could simply run a Terraform apply on a development or a test stage. It doesn't have to be any fancier than that. And once you have this basic workflow in place, you can then iterate and improve on that. What is very important when it comes to bringing your service into production is that you practice any deployments early and often. And as a corollary, don't leave the path to production to the last minute. Maybe now it's the right time to also talk about some challenges when it comes to automating your infrastructure code. So the first challenge that comes to my mind is what we call blast radius, which is the potential damage a given change could make to a system. And this damage is usually based on the elements of the system you're changing and what other elements depend on them and what elements are shared. Another challenge is that when you look at the deployment of modern applications, today we usually see what is called an immutable deployment. So think about a containerized application that you deploy via a container image. So whenever you run an update of this application, what happens is that the old image gets completely replaced by a new image. So there is no in-system patching of config files or starting and stopping processes anymore. It's just bringing a new image in place, spinning it up, and then, for example, redirecting your load balancer to this new container. When you compare that with infrastructure deployment, you easily find a scenario like the bottom line, which means that you incrementally add changes to infrastructure that's already in place. And the challenge that you probably find with this approach is what happens in terms of disaster recovery when all of your infrastructure code suddenly goes away. And the question then is, can you come from a state where you have nothing at all to the last state you had deployed at your cloud provider, for example? And this is especially a problem because usually people don't practice this from zero to latest version frequently. What they do is only applying those delta changes, right? So from version 1 to version 2, it's only the blue box at the top that you apply, and the same holds then for from version 4 to version 5. So what you should keep in mind and regularly practice is whether your infrastructure code also works when you start from scratch. As a countermeasure for this problem of disaster recovery, you might want to rethink how you treat infrastructure changes in a pipeline and design your pipelines in such a way that in a first step, they spin up the infrastructure at the state before the latest change and then apply the latest version. By that, you are testing both. You are testing whether you can spin up the whole infrastructure from zero, and you also test whether whatever you have in production at the moment allows you to apply the latest change to get you into the desired state of the latest change in the infrastructure code. So let's come to the summary of this presentation. We talked about these 3 principles of continuous delivery for infrastructure. Remember principle 1, everything is code and everything is in version control. Principle 2, continuously test and deliver all the work in progress. And principle 3, work in small, simple pieces that you can change independently. If there's one slide that I specifically want you to remember from this presentation, then it's this structure of the infrastructure pipeline. And that we promote a code base that does not change throughout the individual stages of the pipeline, but only gets added different configuration for each environment. A last remark, for those of you who want to dive deeper into the topic, I can really recommend this book, Infrastructure as Code, of my colleague Keith Morris. I think he's currently working on the 3rd edition. I don't know whether it's been released yet, but you find it on O'Reilly. And that's it. Thank you for your attention. If you have any questions or want to reach out, then follow me on LinkedIn or send me an email. And I'm happy to jump on a chat and answer any questions.